Alright, so let's start going over the meat and bones of why people love Golang so much, which is the Go routines. So a Go routine is a lightweight thread managed by the Go runtime. Go routines are multiplexed to fewer numbers of OS threads. Now, what is a thread? A thread is a unit which executes the code under the program, right? So if you don't know exactly what that means, or if you don't know what an OS thread is, I am going to leave a link to a couple articles that helped me understand what it is, but just think of it as a thing that helps execute your code in a program, right? And that's why if you ever heard of multi-threaded applications, meaning there's multiple threads to execute multiple things at the same time, or to help run multiple things at the same time, or if you just have one thread to execute one thing in a specific order. So if you only have one thread, you can only execute one thing at a time. Now, that's where Go routines come into play, right? I already talked about how Go routines are multiplexed to fewer number OS threads, but with that one thread in Golang, you can run thousands of Go routines, right? So each Go routine will execute a specific code instruction. So imagine if you could run thousands of instructions at the same time. That's what Golang provides, and that's why people use Golang so much when it comes to running asynchronous processes, right? So what is synchronous and what is asynchronous? I just said what asynchronous, but synchronous is a thing that has to be executed before it can go on to the next line, right? It runs in order. But asynchronous, right, you could run many things at the same time. It's non-blocking, right? Synchronous is blocking, meaning that you have to wait for something to finish executing before moving on to the next instruction. But asynchronous, you can run one thing and you can continue on to the next, and even while running the next thing, the previous thing that was just ran will probably still be running, and you don't have to wait for it to be finished and to continue on to the next thing to execute. And we'll see examples of this later on in this video. So like I said, you can have thousands of Go routines running concurrently on a single thread, right? This will be able to efficiently go in and out between executions of each Go routine, because Go handles that on the back end. Go routines are lighter in weight than an OS thread, and like I said, I'll put some articles in the description so you can read up on OS threads. But executing multiple threads could be a bit heavy, but Go routines make it lighter to use than normal OS threads, because they use little memory and resources. They use up to the amount of memory and up to the amount of resource that is actually needed to execute what you're trying to execute, right? You don't need to spawn up an OS thread that can be huge and that can be taxing, but Go routines or Go on the back end pretty much brings up the specific amount of memory and specific amount of resources needed to execute that task, compared to a normal OS thread. Now, what helped me realize the importance of a Go routine is an example, right? So say for instance you have an event bus, and if you don't know what an event bus, just think of it as a pipeline that sends events for whoever's on the other side of the pipeline to retrieve that event and execute code based on the type of event. So say for instance, think of a bank, right? And you have a client that's using a mobile phone, and they're trying to either deposit money or withdraw money or pay money, right? And each event is different while they push into that pipeline, right? So imagine a pipe, or the client's on one end, a bank is on the other end. So imagine a person is trying to pay their bill. That's one type of event, right? And for each different type of events, you want to run a different type of instruction on the bank side, right? But imagine on a larger scale. Imagine there's on a normal day, Chase is probably getting millions and millions of different type of events going on, right? Do you think that they can just wait for everybody one by one to do one thing until they go on to the next thing? That would be impossible. People would be waiting for days, right? So you would want to use something like a Go routine to execute these events while also executing other events, right? You don't want to wait for one person to finish. You want to be able to handle these events at the same time, all of them at the same time. So that's one important example to understand on why goroutines are such important to use in times like this, where on a large scale, on a large company, you would want something that's lightweight and efficient to run these events asynchronously. All right. So each goroutine will be attached to each type of event that is being set to chase. So say for instance, somebody's trying to pay their bill, someone's trying to deposit something, someone's trying to withdraw something. Each one will be assigned to a goroutine, and they will be executed, and the user will be able to retrieve a response when that goroutine is done. But you don't have to wait for that person in Idaho to finish depositing his money for the next person that's in Florida to withdraw money that they need. You can do it all at the same time with great speed. And I'm gonna show a nice little quick example on how to do that. But I want to give an example on why it's important to be asynchronous in a time that a lot of people may be using your application. Right? We can't wait for one thing to be finished before we execute something else. We have to be able to execute multiple things at the same time. So let's see how to create a goroutine. All right. So I'm going to create a function which we learned before called printed. Right. We learned how to create a function, but I'm going to call it make a function called printed, and I'm going to just take a parameter called it, and it's going to be a string. And all this is going to do is print out whatever you place as a parameter. And let me actually import this. And I'm just going to create a for loop, right? And we also went over this in the series, but to create a for loop, just create a variable, and I'm just going to make that equal to 0 initially. And while I is less than 5, I'm going to loop through this, but I'm going to increment it each time by 1. And I am going to create a goroutine, right? And what is this? Let me see. Boolean. While I is less than 5. This should. Oh, forgot to put the semicolon. All right, cool. So to create a goroutine in Go is beautiful, right? It's very simple. All you got to do is use the keyword Go. Boom. So that's all you got to do. And this will pretty much run this, whatever you choose, whatever task you put after this keyword as a goroutine. It will run it asynchronously. So what I want to do is I want to print out, while I'm printing this thing out in the for loop, I want to run it asynchronously. So I'm not waiting for this to be finished. I can go on to the next thing. So let me just do print in loop. And let me just do a print up here. Print it, initial print. And I'm going to make another print right here. And this is just going to be an anonymous function. And I'm just going to call this message. And I'm making this a string. Open it up. fmt.println. Going to print out the message. And I'm going to pass in the message as I call in the anonymous function. So this is a message using a goroutine. And then what I'm going to do is I'm going to sleep for a second. Now what this does is that it pretty much pauses for a second. Now we don't have to necessarily pause for a second. If you want to pause for an hour, you can. If you want to pause for a millisecond, microsecond, whatever. But I just want to pause for a second, and I want to print out that I am done. Now, why do I do that, right? Why am I doing this? It's because with a goroutine, because it's running on a separate thread. Actually, let me remove this extra parentheses. But because it's running on a separate thread, right? Whenever I'm running this, when I'm running this main function, you do know by default, if I get to the end, I am done. Like I can close out the main, I can close out the application once it reaches the end, right? Like once I see this line and I get past this line, the application will shut itself off because there's nothing keeping it running, right? So if there is something running in a thread that's not finished executing, if I already, and because it's not synchronous and it's not going to wait for it because it's running on a, on a thread, because it's using a go routine. Once I get past this line, right, this is technically still synchronous. Once I get past this line, it's going to end the program, right? It's not going to wait for the go routine to finish, because the go routine is asynchronous. We're still waiting on the output, but so it's, somewhere, being executed. But since it's not blocking, right, since this is the last blocking piece of code, once it gets past this line, it's gonna end the program, and we don't want that. So we want to wait a second, because honestly, we don't have to wait too long. It's just printing stuff out. So we can just wait a second for it to finish, and once it's done executing, then we can finally print out the last thing, and then you can close out the application. So let's see that. And actually, no, let me take this out. Let me take out the second, and see what happens, so I can show you guys what exactly is happening. Boom, right? So I'm printing the initial thing, right? And I am printing out fin, right? But it was only able to have enough time to print out one thing in the loop, right? All right, so it got to this point, and right before this thing was about to end, I was able to get one thing in the loop, which is right above here. First, you can actually see that it's asynchronous, that it's not waiting for this to start executing and finish executing before it gets to this line. So that's the cool thing about Goroutines, that we're not waiting. It's not blocking. It's just going to the next line. So you can see that it's printing after this. But the bad part is that because this program ended, it only had enough time to print out one thing before it ended, right? Because it's not blocking. It's not blocking the application from stopping. We're not waiting for this to finish executing, because it is running on a separate, go routine, separate thread. So if we want to wait for that, we may have to use, the time library to, stop for a second, just so that we can see it. But the cool thing is that we can see that it is asynchronous, that we don't have to wait for it to finish executing this loop to actually run, right? It runs, and whenever it's finished, that's when it will output. And yeah, that's the cool thing about Goroutines. Now, if we actually want to see it finish, let's do that. All right, so let's run it, and boom. All right, so we're able to see, okay, initial print, which is this. This is a message using the go routine. So actually, it didn't even print this out first. It actually went to this second go routine, and since it's just a simple print, like one print to actually execute. I guess this was a bit faster than actually running the for loop. So this printed out first before it actually printed everything in the loop. And then, since we paused for a second, we're actually able to finally run this last line of code, which is fin, and then it ends out the code, which is cool. This is the expected behavior. And because when using go routines, we don't necessarily know when that go routine will actually return. Some may be faster than others. In this case, it kind of is expected for this to be faster, because we're only, like I said, printing out one message, which is the parameter, and then this is more of a for loop, so it's it might take a little bit longer. But we can see the usefulness of a go routine because it is not blocking. We can run whatever we need to run, and it'll it'll execute whatever it needs to execute and return a response based on that. So like I said, think of a bank. Think of a bank on how it's receiving so many requests for people needing money or needing to take out money. And imagine if we had to sit here and wait for each line to execute. No, we don't want that. If we know that we need to return money to somebody, we should do that on one thread or one go routine. And deposit need to be done on another routine, and everything is probably stored or withdrawn from individual databases. Every event probably has its own way of doing things. So say for instance, they probably have a switch statement, right, on a very basic level, a switch statement that has deposit, withdraw, transfer, and each event has its own go routine, and based on the event that's passing through the event pipeline, it runs a go routine using that switch as a way of categorizing everything. So this is powerful. I would play around with this, but this is just a very basic implementation of a go routine. You guys, like I said, can play around with it and try to code what exactly I just said. Try to execute based on the switch statement, execute a specific Go routine. And I believe this is useful in a server, because a server doesn't just end like this. It's going to continue listening on a port until maybe the application crashes, or maybe you restart the server. And I'm going to go over that in my next series, where I'm going to show how to create a Go API server, and we'll use that even more in that series, to show you exactly how this is useful for handling events. But I wanted to demonstrate a very basic implementation on how Go routines are non-blocking and how they execute things given the right amount of time, and how if you don't give it the right amount of time, it will end the application, and it won't be able to execute the Go routine fully, as long as you don't give it enough time to do it. But it is still running technically, but if you end the application, it's just never going to run it. So hope you guys understood that. If you need any assistance, or if you need better understanding, check out the description. I'm going to put some stuff on OS threads and more information on Go routines, some articles that I felt helped me out. And in the next video, I'm going to be going over channels, how to communicate with Go routines, how can individual Go routines communicate with each other, how can they return messages and communicate with each other. So hope you enjoyed it, and stay tuned for more.